I'm Jef Leroy. I'm a Senior Research Fellow at IFPRI's Poverty, Health and Nutrition Division, and we are in my office today. So chronic malnutrition remains an important global public health problem. It's estimated that currently we have 159 million children under 5 that are stunted. And stunted means that children are too short for their age when we look at or when we compare them to the international growth standard. Now, one of the questions that has intrigued nutritionists for many decades is whether this process of linear growth retardation or stunting can be reversed. And this reversal is most often referred to as catch-up growth. And up to recently, the consensus was as follows. Children who remain in the environment where the stunting occurred in the first place remain stunted, so we don't see any improvement in growth in those children. Whereas children whose environment is improved, and that could be through nutrition and health interventions or through adoption, in those children we can see improvements in linear growth. There is one key condition though. These improvements in the environment need to happen at a very early age, and we generally believe it needs to happen before the age of 2. Now, quite recently, a number of studies seem to have shown that catch-up growth is possible, and they seem to challenge this common view that we had before. Now, before we talk about these studies and what we did, I want to explain what catch-up growth really means. Based on the International Growth Standard, we know that children on average grow by this much in utero. In the first year of life, they grow by this much, and in the second year of life, they grow by this much. So by the time the child is 2 years of age, on average, we expect them to be this tall. Now, children growing up in deprived settings grow slower. So in utero, on average, they may only grow by this much. And in the first year of life, they will only grow by this much. So by their first birthday, we can clearly see that they have accumulated the deficit of this size, shown in red. Now, catch-up growth means that the size of the deficit is reduced. And the only way to do so is for the child to grow faster than you would expect based on the growth standard. If the child in the second year grows faster, you can see that the deficit is now smaller than it used to be. So catch-up growth means that 1, the deficit children have accumulated is reduced. And the only way to do that is to grow faster than you would expect based on the International Growth Standard. 2 things are surprising about the recent catch-up growth studies. The first one is that they document catch-up growth in children 2 to 5 years of age, which is after the age at which we generally believe that catch-up growth is impossible or that any improvements to linear growth is very difficult. And secondly, they document catch-up growth in children who remained in the poor environment where the growth retardation or the stunting happened in the first place. We reanalyzed the data used in some of these recent studies to evaluate the validity of these new surprising claims, and we found no evidence of catch-up growth in these children. As a matter of fact, in the children that were previously identified in these studies as catching up, rather than a deficit going down, as these studies claim, we found that the deficit in these children increased with age. So what explains the difference between the studies conducted on catch-up growth and our findings? Well, it all relates to the measurement of chronic undernutrition. Typically, chronic undernutrition is measured using height for age Z-scores. They provide an easy, useful way to assess and compare children in countries or groups of children across time periods using the International Growth Standard. We have shown, however, that height for age Z-scores are statistically incorrect to assess changes in children's height as they grow older. And we propose the use of a different metric, which we call the height for age difference. It's a simple difference between how tall a child is and how tall a child should be based on the International Growth Standard. So using this new metric, the HAD or height for age difference, we found a complete absence of catch-up growth. And actually, when we looked at the data, we found a steady increase in the deficit from birth 2 up to 5 years of age. Now going back to the decades-old question, is catch-up growth possible? It might be, but there are 3 important things to consider. The first one is that catch-up growth is unlikely in children 2 to 5 years of age if they remain in the poor environment that led to growth retardation or stunting in the first place. The second take-home message relates to measurement. We show that using HAZ scores is not the proper tool to assess catch-up growth. And the third point that is important is the following. It relates to the other consequences of growing up in poor conditions. We know that poor environments, poor health, poor nutrition leads to linear growth retardation and stunting. We also know that it leads to problems with cognitive development, poor school achievement, lower labor productivity, higher mortality, and higher incidences of non-communicable diseases. So the key question is whether interventions that lead to better growth in children and may thus also lead to catch-up growth can also prevent these other outcomes from happening.